Hello, and welcome to Solving Linear Equations. This will be an intermediate algebra level approach. Start with a definition. A linear equation is an equation containing a variable that is raised to the first power, and frequently we do not write the first power. These equations will generally have one variable in the rule of the equation and another variable that names the equation. Frequently we use f for a function, but we might name it depending on the actual problem. For example, we use R frequently for a revenue equation, and revenue is the amount of money brought into a business through sales. Revenue is often calculated as revenue is equal to price times the quantity sold. Suppose you were going to buy 3 webcams, so that's 3, and they are $30 each. You have just paid $90, the company has just made $90 revenue from their webcams. Of course, it's not all pure revenue, as we have costs, and we'll call cost functions C, because we're so clever. The amount of money spent by a business to create and or sell a product. Cost usually includes both fixed costs and variable costs. Now, fixed costs are the same each month or year, like salaries and rent or mortgage or whatever, if they own the building or not. Variable cost change, right? It varies depending on the number of items produced and or sold. And when we put revenue and cost together in a specific way, we find that the profit is the amount of money left after all costs. So profit can be found by taking revenue and subtracting all the costs you had to pay. Now, the break-even point is what companies look for, because a company breaks even when their revenue is equal to their cost or when their profit is 0. Either way, we will have a break-even. All right, so let's do a few examples of this type. You plan to purchase custom-printed lunch coolers for your school staff. If you order 50 or more lunch coolers, there will be a $45 setup fee, and each lunch cooler will cost $3. So write an equation for the total cost C. So let's give this a little, that's not what I wanted. I wanted a highlighter, total cost C, for purchasing L lunch coolers. It's a good idea to always identify your variables so you know what they're talking about. Well, I know that the cost is equal to $45 no matter what, the setup fee, plus $3 multiplied by the number of lunch coolers that we decide to purchase. All right, that's it. One variable naming the function cost, and another variable inside telling us what it is that varies. You will occasionally hear my dogs in the background because dogs will not be shushed, and that's okay. So if I have 75 lunch coolers, this tells me that 75 is equal to our L value. So we can find our cost. Cost is 45 plus 3 times 75, right? Instead of that L, we'll have a 75 in place. We go over here to our handy calculator. Always turn it on. This is a Wabbit emulator I got free. I recommend it. It's fantastic. 45 plus 3 times 75 is 270. But remember, this is a cost. Let's not forget the units, right? $270. Now, how many lunch coolers can you purchase with a budget of $400? So how many lunch coolers will tell us to find L? All right, so a budget of 400, this is a cost, so I'm going to put 400 in for my cost. I'm going to write this in the worst place possible, it seems. In order to solve, we'll subtract 45 from both sides. I'm going to take this line up over here. 45 minus 4, let's say this correctly, 400 minus 45 seems very much like 355. Equals 3L. To get L by itself, let's divide both sides by 3. And we'll have L equals, let's just check that out on our calculator, 118.33. And that 3 is repeating, so I'll put a line over it. But really, are you going to buy somebody a third of a lunch cooler? No, let's answer these in real world terms. We'll have 118 lunch coolers. We cannot finish, right, that 119th one. We have the budget for 118 and a part, so we'll have 118 complete lunch coolers. All right, it looks like we have some bad spacing here, so let me see if I can grab my pointer tool now. No, I cannot. That's all right. I'll just go with what we have. Determine which given value seems the most reasonable for the given situation. So S is a cook's monthly salary. In dollars from working at White Castle Hamburgers. So does it seem reasonable that the monthly salary would be $10.50? Monthly? No, definitely not. So we'll strike that out of the options. A monthly salary of $1,600? Possible. Do you think it's possible that working at White Castle as a cook, tasty, tasty White Castle burgers, could they make $28,000 per month? Probably not. So the only possibility is this one, about $1,600 a month as the monthly salary. All right, so always check reasonableness in your math problems. One more. The Squeaky Clean Window Cleaning Company, say that 3 times really fast, has several costs included in cleaning windows for a business. The materials and cleaning solutions cost about $150 per window. Insurance and salaries for the day will cost about $230. So if we look at this, we have per window will be variable. All right, so that's it changes depending on the number of windows they do. So this is the one that will have the variable associated with it. Each day, this will be a fixed amount, $230 each day plus $1.50 per window. So let's take a look. Write an equation for the total cost to clean windows for a day depending on the number of windows cleaned. Let's use number of windows as n. So the cost is $1.50 multiplied by the number of windows cleaned. Add to that the $230 fixed cost. If the company cleans 60 windows, $1.50 times 60 plus 230. Well, 1 times 60 is 60, and half of 60 is 30. So $1.50 times 60 is 90, plus 230 will give us a cost of $320. All right. So how many windows can the company clean if the total cost cannot exceed a budget of $450? All right, we can't go over. So if we have $450 for the cost, we want to find the number of windows that we can clean. So let's subtract 230 from both sides. 450 minus 230 is 220. And when we divide by 1.50, we'll end up with n equals, this is probably one I should be able to do in my head, but when you're doing a video, and sometimes when you're just doing math, it's always nice to have that backup of the calculator. Oh, what do we have? 146.6. But they can't exceed $450, so they can clean 146 whole windows. Nobody wants 2/3 of their window cleaned, unless they're super short and they can't see out the top anyway. No, nobody wants 2/3 of their windows cleaned. All right. Notice how the problem started with words, and I finished it with words. It's always a good idea to be able to sum up a word problem with the words that kind of take it back on the problem itself. Golf Carts to Go sells refurbished golf carts in Southern California. The company has a fixed cost of $26,000 per month for rent, salaries, and utilities, but it tells us right here these are fixed cost. They can buy used carts and refurbish them for, they could buy for $1,400 each. So if the company's buying those, that will be a cost. They sell the carts for an average price of $2,500 each, and only 55 carts a month. This is an upper end restriction that we have to keep in mind. All right. So write an equation for the monthly cost of refurbishing N carts. So the cost is 1,400 multiplied by the number of golf carts they buy plus 26,000. All right, that's it. Now, if I want to write an equation for the monthly revenue from selling golf carts, the revenue, that's the money they bring in. Let's call it R, because we're so creative. The revenue is $2,500 multiplied by N. Notice there's no guaranteed revenue. There's never a fixed revenue. Write an equation for the monthly profit. Okay, profit is revenue minus cost, and that will be our 2,500 N minus, and then since we're subtracting, we have to subtract the whole thing. 1,400 N plus 26,000. I encourage the use of parentheses here so you remember to distribute that negative. We end up with a profit equation of 1,100 N minus $26,000. So after we overcome that $26,000 cost of just rent and all of that, our profit will be $1,100 per golf cart. All right, so what's the profit of refurbishing and selling 25 golf carts? The profit at 25, 1,100 times 25. Whoops, make sure that's a minus sign there. Minus, that's the most frequently made error on this problem. 1,100 times 25 minus 26,000. 1,100 times 25 minus 26,000. We'll just do the whole thing on our calculator here. Get 1,500. So they will profit $1,500 selling 25 golf carts. As a C. All right, how many golf carts does the company have to refurbish and sell to earn 20,000? All right, so we only made 1,500 profit in refurbishing 25 golf carts, so we know it's got to be more than 25. Let's see how many it is. I want a profit of 20,000, so I use the profit equation. 25,000 equals 1,100 N minus 26,000. Our first step will be to add 26,000 to both sides. Let's make sure we put the addition symbol there so we don't get all crazy. Let's bring it up to this next line. That looks like 51,000 equals 1,100 N. And if we divide both sides by 1,100, my dogs like to have fun. They're good pups. 51,000 divided by 1,100, I end up with 46.36, and that 36 is repeating golf carts. So in order to earn 20,000, they actually need to sell that 47th golf cart. All right, think about the question itself and not just how to round mathematically. Mathematically, if we round it, it rounds to 46. But 46 and a little more than a third will make the profit of 20,000. In order to actually earn that full 20,000, we have to add one. We have to complete that 47th golf cart in order to make that profit. All right, let's keep going here. To earn 40,000, we'll do the same thing. 40,000 equals 1,100 N minus 26,000. Let's add 26,000 to both sides. And we'll have 66,000 equals 1,100 N when we divide both sides by 1,100. We end up with, let's see, 66,000 divided by 1,160. We probably should have known that. I should have known that. But keep in mind, the company could not do more than 55 in a month. So there is no way for the company to earn 40,000 in a month. 55 is max, and 60 is needed. Now, normally I'm kind of at the time where I'd like to stop the video, but the next section is so short that I am going to keep going. It's the last page. It's just a little bit of a review. So that was solving linear equations in terms of words, but let's look at just some variable problems. In order to solve a problem of the type 3/4 x minus 17 equals 20, we have a couple of ways we can do it, and I'm probably going to do it differently for each one of these problems. So I'm going to give you several different methods. For this first problem, I could just add 17 to both sides. 3/4 x equals 37. Now, instead of dividing by 3/4, when we have a fraction, maybe we want to multiply by the reciprocal on both sides. Because when we multiply by the reciprocal, right, on the left side, 4 times 3 is 12, 3 times 4 is 12, 12 over 12 is 1, so we have x. On the left side, we'll have, let me see, there's no simplification here, so a 37 times 4 is 148 divided by 3. In this one, we will not find the decimal. We'll leave it as 148 divided by 3. It does not simplify. The fraction does not reduce at all. And mixed numbers are only used for baking and carpentry. So let go of those mixed numbers. Let's leave it as 148 over 3. But on a problem like number 2, I don't want to do that, right? There's more than one fraction here. So what I'm going to do on number 2 is I'm going to find my least common denominator. I'm using 8, I'm using 9. So 72 is our least common denominator. Now, since we have an equal sign, what we're going to do is we're going to multiply 72 by every single term, even if it doesn't have a denominator. I'm going to multiply 72 times 3/8. Let me use a black pen here. 72 times 3/8 p minus 72 times 4/9 equals 72 times 5/8 p plus 72 times 7. And it looks like I wrote a 75 there. Let's make that go away. Let me get this back here. There we go. Let's make sure I use the correct numbers, or else this will not work out. Now, as I'm looking through these, all right, notice that 72, least common denominator, 8 goes into 72 9 times. 9 times 3 is 27p. 9 goes into 72 8 times. 8 times 4 is 32. 8 goes into 72 9 times. 9 times 5 is 45p. And 72 times 7, let's see, 7 times 7 is 49, and then I have a 14, so that's 502. No, it's not, it's 504. But now that I've said that wrong, let's just check and make sure I've got the right value. All right, 504, we're good to go. Now this is a problem we can all do. It's fairly straightforward to solve. I'm going to almost always, take my variables to the left. I decided a long time ago that I don't like making decisions, and so I automatically always just take my variables to the left, and I'll take my numbers to the right. And let's bring this up, and I'm going to switch colors yet again. 27p minus 45p, let's make sure we get this right, is a negative 18p. And this equals 504 plus 32 is 536. When I divide both sides by the negative 18, I'll end up with p equals, see, 536 divided by, make sure you use the negative button, not the minus button, divided by the negative 18 is nothing that we like. Whenever this happens, we can use the math button, turn it into a fraction, and we find that this, we can divide each of these by 2. We'll have negative 268 divided by 9. P-value. There we go. So we don't want the decimal. The decimal is not going to be a good answer, particularly for my students using WebAssign. We'll want the exact answer in fraction form. Again, for number 3, I see only 2 terms. I see one term on the left side and one term on the right side. Terms are separated by plus or minus signs. But when you have a plus or minus sign inside the parentheses and something's being multiplied, this is one term on the left for number 4, 2 terms on the right. Okay, so here I have one term on the left, one term on the right. So I'm going to multiply both sides by 7. And I'm just going to write it right there. 7 times the left side, 7 multiplied by the right side, and these 7s will cancel. I end up with 3 times 2z minus 5. My z's will always be crossed, otherwise they look exactly like my 2's. Let me start writing some better numbers here. So we distribute. 3 times 2z is 6z minus 15. On the right, we'll distribute the 4 minus 12z plus 36. Let's add 12z to both sides. I'll end up with, I'm going to write this up here, 18z minus 15 equals 36. Up in problem number 2, I did this all in one step. Some of you might prefer the 2-step method instead, so I'm going to use a little 2-step method. That is 18z equals 51. And when we divide by 18, we end up with z equals again we're going to get the decimals. Now I'm totally using a cheater's method here. Cheater's method using the calculator to simplify my fraction. But a little side note here. How do we simplify fractions? 51 over 18. First of all, I know 3 goes into both of these because I know they're both not even. 3 goes into 51. Let me see. 3 goes into 5 once. 5 minus 3 is 2, 21, so 17. 3 goes into 18 6 times. And there we have our 17/6. All right, so we could reduce that by hand if we wanted to. Last problem. Let's get this one taken care of, and then the recording will be over, and you could go ace your homework. I have 2 fractions, but I have 3 terms. It looks like my least common denominator will be 28. And we'll talk more about least common denominators later in later recordings, but for now we're just going to assume that knowledge. If you need to look it up, you should do so. We're going to multiply 28 on the left side. We're going to multiply 28 times the fraction and 28 times the minus 15. So what does this look like? We will have 7 goes into 28 4 times. 4 times a negative 2 is negative 8, and I haven't done anything with anything in the parentheses. On the right side, 28 and the 28 cancel out, and we'll get 3x minus, and 15 times 28, probably could do that in my head, but I'll be honest, I'm not feeling it. This is 420. All right, so now we distribute. Negative 8 times 4x is a negative 32x. This is a 2. It looks like a 7, so let me fill that in there. Negative 8 times 2 is a minus 16. Equals 3x minus 420. Let's go ahead and subtract 3x from both sides. We'll get a negative 35x. I'm all for saving room, so I'm going to add 16 at the same time. And we'll get equals a negative 420 and a positive 16 will be a negative 404. So when we divide both sides by a negative 35, we have, since they're both negative, negative divided by a negative is positive. 404 divided by 35 is ugly. So that's where it's going to stay. The only thing we could do in order to simplify this fraction is take care of our signs. All right, let's circle this answer as well. That's it for solving linear equations. Best of luck on the homework.